You might remember in the previous section we used components to add vectors. We're basically going to do the same thing in this section, except they're going to be more formed in new situations. So, for example, two cars are pulling a crate with chains as shown in the figure. Using components, find the magnitude and direction of the resultant force vectors. Okay, the big thing to watch for here is in most of these problems, the angles are not given in standard position. And we always have to use standard position. So for example, this angle right here, we have to call it negative 31.0 degrees. And then notice they're giving us this angle is 19 degrees. That's not an angle we can use. We really need this one, which would be 270 would be 3/4 of the way around. So that's 270 minus 19. We have to call that one 251 degrees. Okay, so now that we have the angles in standard position, now we can find the components, and from the components we can add the vectors. I'm going to call this one vector A and this one vector B, just for no reason in particular. It doesn't matter which one's A and which one's B. So I need to find A sub X and A sub Y, B sub X, B sub Y, and then I will add those to get R sub X and R sub Y, where R is my resultant vector, of course. So AX, that's 458 cosine negative 31 degrees. And AY is 458 sine negative 31 degrees. So remember that when you're finding your components, that X always uses the cosine and Y always uses the sine. All right, and then BX is going to be 725 cosine 251 degrees. And BY will be 725 sine 251 degrees. All right, so grabbing my calculator here. Let's make sure I'm in degrees mode. I am. That's good. 458 cosine negative 31 plus 725 cosine 251. So RX is 156.55. I'll go to two decimal places here for no particular reason. 458 sine negative 31. Make sure you close that parenthesis. Easy to forget to do. 725 sine 251. RY is negative 921.39. Okay. And then we find R. We use R squared is RX squared plus RY squared. So R is, again, really, I'm not going to write it down. I'm just going to do calculator work here. 156.55 squared plus, make sure you put this one in parentheses because it's a negative number, negative 921.39 squared. And then we would do the square root of that. So R is 935, I'm going to call it. Since these had 3 significant digits, I'm going to give 3 significant digits in my final answer. And then to find theta, we use tangent theta is Ry over Rx. But we do need to be careful and think about where is our answer going to be. It looks as though our answer, I mean, it's being pulled this way and that way. So our answer's got to be either in quadrant 3 or quadrant 4. So we've got to be careful when we use our calculator here. So to get rid of the tangent, I do tan inverse of negative 921.39 divided by 156.55. And I see that it's giving me an answer of negative 80 degrees, which is down in this zone, down in either quadrant 3 or 4, so that's believable. But you need to be careful. I mean, if it gave me an answer like 70 degrees, which would be up here, I would say, well, that's clearly not the right answer. I really need to convert that to quadrant 3. So be careful of finding your angles here. I'm going to give this 1 decimal place of accuracy, negative 80.4 degrees. Since my original angles had 3 significant digits, I'll get 3 significant digits. Okay, so really not a lot new compared to what we did in the last section. It's mostly just making sure our angles are correct. All right, so here's another one. It says, a plane is heading 38.5 degrees west of due north at a rate of 182 miles per hour. Now, if you're a pilot, this is how you measure angles. Pilots measure angles from due north or due south. They don't measure from the x-axis like we do. So they're telling us that angle's 38.5 degrees. Again, we can't use that angle. We need this one. So that's 90 plus 38.5. So we need to call our angle 128.5 degrees. And wind is blowing at an angle of 75 degrees east of due north. So they're giving us this angle, again, measuring from due north, at 17.5 miles per hour. Again, we need the angle in standard position. That's, what, 15 degrees. Using components, find the magnitude and direction of the resultant vector. All right, I'm going to call this vector P for plane, and this one W for wind. So, much like last time, I need to find Px, Py, Wx, Wy, I wrote X there, add them together to get Rx and Ry. Alright, so Px is going to be 182 cosine 128.5 degrees, where Py will be 182 sine 128.5 degrees. Wx is 17.5 cosine 15 degrees, and Wy is 17.5 sine 15 degrees. Now you'll notice that I'm not calculating these and writing down equals. I'm just going to do it all in my calculator, all in one step. I don't really need to know the intermediary values, so I might as well just do it all together. 182 cosine 128.5, close that bracket, plus 17.5 cosine 15. I get negative 96.39. And then finding the Ry, 182 sine 128.5, close the bracket, plus 17.5 sine 15, 146.96. So again, notice I didn't get a decimal for Px, I didn't get a decimal for Wx. Just type it into your calculator all at once and add them together. It's cleaner that way. Alright, and similarly for finding R squared is Rx squared plus Ry squared. So again, I really don't do all the intermediary work, I just do it all on my calculator. R is negative 96, make sure you put that in parentheses, negative 96.39 squared plus 146.96 squared, and square root that answer. So R is 9640. Again, I'm going to give 3 significant digits because these had 3 significant digits. And tangent theta is Ry over Rx. So theta is tangent inverse of Ry, which was 146.96, divided by negative 96.39. Negative 56 degrees. Okay, that can't possibly be the right answer. because negative 56 degrees would be down here, right? So it's got to be the answer in quadrant 2. It's got to be that one, which means we have to add 180 degrees. So again, be careful. Look at your problems when you get your angle. Make sure your angle makes sense. The calculator is always going to give you angles in quadrant 1 or 4. If your answer looks like it's in 2 or 3, then you got to fix it. That's all. 123.3 degrees. All right, going to pause, save this video, and then in a little while I'll make the other video and I'll upload it and post it for you.